Hi. Today's topic is solving one-step equations. So that's what we'll be working on for the next week or so. And there's basically just one rule when you're solving one-step equations, and that is you have to isolate the variable by using the inverse operation. And we call that the double I rule. I love to put two eyes, like real eyeballs, with the double I rule. And the reason I call it double I is because isolate and inverse, they both begin with the letter I's. So isolate means that we have to have the variable alone. We're putting the variable in isolation. So you know, isolate means you're all by yourself. You're standing alone. Then inverse means the same thing as reverse or opposite. So the inverse operation of addition would be subtraction. The inverse operation for division would be multiplication. It's just the opposite operation of the one that's given. So the major rule, remember, is to isolate the variable by using the inverse operation. So I have two examples here, and we're going to go through them together. Here we have 66 plus n equals 96. Now, a lot of you could use mental math and figure out exactly what that n equals. Does anyone want to shout it out? Pardon me?
I'll let you know.
30, sure, good job. I know we're a little dusty-brained from spring break. But a lot of you could use mental math and figure that out. But I want you to be mindful that the problems are going to be getting more difficult. And mental math, it might be a little bit more challenging to solve using mental math. So that's why we have the rule of isolating the variable by using the inverse operation. So here we have 66 plus n equals 96. And we're trying to get that n by itself. We're trying to isolate it. So how we're going to do that is use the inverse operation that we see in the equation. What operation is this?
Addition.
Addition. So what's the opposite of addition?
Subtraction.
Okay. So we're going to subtract 66, because remember we're trying to get rid of that integer so that we have the variable by itself in isolation. What we do to this side of the equal sign, we do to the other. Okay? Because we have 66 minus 66, what value is that? Zero. So we just cross it out. We bring down our n, because it's all by itself now, and we bring down our equal sign. And then if you subtract 66 from 96, you'll get 30. And that's our answer. So let's go ahead and plug in the value of n and make sure that our equation is true. So it would be 66 plus 30 equals 96. And we do have a balanced equation because the value on this side of the equal sign is equivalent to the value on this side of the equal sign. Okay? The next example we have is using division. So we have r divided by 2 equals 9. We're going to apply the double I rule to solve for this variable r, to solve for the equation. What's the opposite operation of division?
Multiplication.
Pardon me?
Multiplication.
Good. So we're trying to get that r by itself. We have to get rid of that 2. So I'm going to put times 2 on this side, and that will cancel it out. And whatever I do to one side of the equal sign, I do to the other side. So I'm going to do times 2 over here. And what's 9 times 2? 18, good. Remember, we're going to bring down our r, that's by itself, and we're going to bring down our equal sign. So r would equal 18. Let's go ahead and plug in that variable, plug in the value of that variable to make sure it becomes an equivalent equation, okay? So we'll say 18 divided by 2 equals 9. So we replaced the value, we replaced the variable with the value. So in conclusion, we're using the inverse operation to isolate the variable. That gives us our value for that variable. Let's try more together.